I've come to the conclusion that the best way to put this class online is to demonstrate many of the homework problems, which I intend to do. Here we have some data, and the first thing we notice that there are 7 classes, and that for each class there is a certain amount of frequency. And so we were about to make certain observations on the data. We notice that we cannot have any overlaps in the classes. As you can see, you can go from 39 to 40 and later from 44 to 45. There cannot be any overlap. Also, we want to calculate the class midpoint by taking the lowest number, adding it to the highest number, and dividing by 2, as you can see in the first example. The class width is found by taking the lowest numbers and subtracting them from the highest number and dividing by the number of classes, in this case 7, and we come up with a number. But notice that we have to round up. The class boundary is found by taking the halfway point between the highest number of one class and the lowest number of the following class. For instance, when going from 39 to 40, we will find the midway point would be 39.5, and this is for the purpose of rounding when entering new data. Here we take the same data, which was for daily low temperature, and the first thing we do is take all the frequencies and take the sum of all the frequencies, and we find that it is 35. Next, we take the frequencies and divide them by the sum of frequencies, and now we become a percentage, and this is called the relative frequency. As you can see, we calculated each for each class. Then we add all the frequencies class by class until they equal the total frequencies. And this is going to be used for graphing purposes later on. And this is called the cumulative frequencies. Here we're working with a large group of data for body mass index. And the first thing we were asked to do is to create a class width of 6. So we start at 15 and we go up 6 to 21 and so on. When working with a large group of data, we simply put a mark each time we find a piece of data within each class. And then pretty soon we have a sort of graphical representation of the relative size of each class. We say that the data looks normal, and by normal we mean there is more in the middle of the data set as opposed to the extremes, and more on this later on. Here we have taken the data from the body mass index and created a histogram to get us a better picture of the data. Notice that the frequencies are always on the y-axis, and also notice that the width of the bars of the histogram conform with the class widths of the original data. Also, finally, notice that everything must begin from 0. The x and the y-axis must always begin at 0. A stem plot is a clever way of creating another visual representation of the data. This time we're using the actual rightmost digits of the data to create a kind of a graphical representations. So the 2 left digits are the highest number because we're plotting in hundreds of feet. And then the right digits are the ones that we're concerned with. Here we have taken the data from the stem plot of the Old Faithful geyser, and then we've turned it into an ogive. And the ogive is cumulative in nature, that is, it accumulates the frequency so you can see when you have a wide variety of measurements, in this case, eruptions of the geyser.